have a leftover bit, don't we? This leftover bit right here is what we need to add to our equation. We're going to have to do it to both sides, right? Because you can't just add it randomly.
Didn't we do a lot like this last semester?
So, what do we need to add to make this a complete square? Well, if you look, this square is x plus 6 by x plus 6, right? What are the dimensions of this thing right here? Looks like 6 by 6, right? Because it's an x plus 6 square, right? X plus 6 over here should be x plus 6 there, x plus 6 there.
But that's so small for
So this is a 6. I know, I didn't draw it to scale, okay? But because that's 6, that has to be 6. And because this is 6, right? That has to be 6. Do you see that now? Okay, good. Seeing it now is what I care about. So that means this right here has an area of 6 squared, right? Which is 36. I'm going to write 6 squared. Okay. But it's going to be 36. So what do? We took this equation. We took this number, we cut it in half, and then we added it on. Got to do it to both sides, right? We added 6 squared. What is 6 squared?
36.
We add it to both sides. And then this all together, right? X squared plus 12x plus 36, x squared plus 12x plus 36 is a square, isn't it? So we should be able to write it as something squared, right? It's squared. What is it? What is it squared? What's the dimensions of this square? X plus 6 times x plus 6. This is x plus 6 squared, right? X plus 6 put on a square. You see it now? This length right here is x plus 6. X plus 6, because these are all 6's, right? And this is x plus 6. So what is this square? Well, after we do all this, x squared plus 6, x plus 6, x plus 36, when we do all that, another way to write that is x plus 6 squared, right? Do you see how I completed the square by adding this little bit in? I added on this, and now we have a complete square. So this should be the same thing as x plus 6 squared. Now we added on that 36, right? So what we have to do is we have to subtract it over, and what do we get? Y equals quantity of x plus 6 squared minus 36. Now, how do we know if we did math and didn't just like change the problem? We should be able to go back, right? So if that is the same thing as this, right, with the plus 36 added on, then we should be able to go back to it. Let's see if we can do it. So here we are. How do I get from vertex form to standard form? I distribute, right? I write it like this, because that's what it means to square something. And I distribute. Let's do it. X gets distributed. What's x times x? X squared. What's x times 6? Now you'll notice when we have a perfect square, these numbers end up matching, and we know that because, look, we had to cut it in half, right? So what's 6 times x? And what's 6 times 6? Don't forget your x's, stalk them on Instagram. Right? Right? I got from here to here. You with me?
No, I was.
Okay. So now we've got x squared. What's 6x plus 6x?
Well, then.
What's 36 minus 36?
0.
Right? Subtract 36 from both sides. That's what we started with. That was the original.
Told you.
Right? So, would you know how to do this just like pulling it out of your butt? No. But if you think about what's actually going on behind the scenes, what this means, you can come up with it. It's x plus 6 and x plus 6. That's what the square is when you have x squared plus 6 plus 6. Now, we didn't have this. We had to make it a square so we could get that, right? So the question is, what's the missing piece? That's what we need to do. We need to find out what that missing piece is. Now, if you notice, what is that missing piece always going to be? It's always going to be half of whatever we started with. If we start with a 12x, those will be 6's, right? Because we cut the rectangle in half and set them on the sides. And so this will be 6 squared. So what's the trick to find out what we have to add? If I give you an equation, how big will my rectangles be when I cut them in half? 24, right? So if they're 24, I know that doesn't look like 24. How big will the missing piece be? 24 squared. Right? They're both 24. That's a 24 side, that's a 24 side, so 24 times 24 is 24 squared. So the algorithm, right? You're not going to bust out a square every single time, right? Cut that in half and square it. Cut it in half and square it. That's what we're going to add on. And it's going to complete the square so we can write it as something squared, which is what we want in vertex form, right? So let's experiment with that.
Can I have those three? Yeah, I do.
Share with the class if they want it. Yeah. All right, let's do another example. Here's an equation. Let's do standard form. I want even numbers because I'm going to divide that number in half, right? If it wasn't even, we get a fraction. We could still do it. But I don't want to throw you in the deep end yet, right? We don't want to have to deal with fractions we don't want to, right? So let's make up an equation. Y equals, give me a parabola, so I need a, I'm going to start with x squared. We won't worry about an a value that isn't 1 yet. I'll show you how to deal with that. Give me an even number for b, 24. Give me a c value.
12. No,
Oh.
6.
6? Give me an odd number. Something crazy, right? 7. Okay, fair enough.
25.
I don't want to give something and you guys think, oh, 12 and 24, they go together, right? No, 7, okay? Random number. Now, odds are, we've got a square, a rectangle, and then this thing, right? They're not going to make a perfect square. So what we need to do is figure out what we need to add to make that perfect square. Well, using the visual, and then eventually we'll cut that out, okay? What we have is x squared, right? X by x. That's x squared. And we're going to add this rectangle to it, 24 by x. Now, we need to cut that in half so we can put it here and here, right? What's half 24? So that'll be a 12 by x rectangle. 12 by x. That's x because this is x, right? See how they're all the same length? That's 12. This is 12. That's x. So that's 12 by x for the rectangle, right? So what do we need to add to it? 12 squared, right? So here's what we're going to do. We're going to do y equals x squared plus 24x plus 7. And we're going to add 12 squared to both sides. Gross. What do I get? What's 12 squared? 144. Now, I'm going to move the 144 here, and I'm not going to combine it with the 7. Okay? I'm just going to switch those. Is that okay? The reason for that is because all of this is now a perfect square. That 7 I didn't do anything with, did I? Right? That's just extra bit. Okay? But this should be a perfect square, right? Because we have x squared plus 12x plus 12x, 24x, right? Plus 12 squared. That should be a perfect square. There should be a way to write that as a square, right? Well, what are the dimensions of our square? How long is the side? It's not x. It's not 12. It's x plus 12. Right? You're adding them up. That's the whole length. What's the whole length here? Well, it's a square. It should be the same thing, right? X plus 12. So x plus 12 put on a square is what this is. Right? X plus 12 squared is the whole thing. They're the same. You can do x squared plus a 24x and then plus 144, or you can just call the whole thing what it is. X plus 12 by x plus 12. X plus 12 squared. Now, we're not in vertex form yet because y has to be on its own, right? So what do?
Subtract 144.
That's true. We've got 7. We're subtracting 144 from it. Let's just subtract 4. How much is left over?
3.
Okay, now subtract 40. Negative 37. Now subtract 100. Negative 137. Right? Vertex form. What's my vertex? Negative 12, comma negative 137. Remember, you got to change the sign for the vertex.
Science.
Right? No talent. No talent. Anyone see that episode? Right? It was in the interpret dance. Whatever.
Yeah.
I like them apples. Do you know why it works? That's why they call it completing the square. Most math teachers are like, we're going to learn completing the square. It's a thing where you cut that in half and you square it and you add it on both sides. And then it becomes this. The number you cut in half was 12, so you put a 12 inside here. Why? I don't know, because that's the steps. That's what you do. That's what you do. That's what we do. And then we get the answer. And I'm going to memorize it.
No, that's not.
Complete the square. Square plus rectangle plus a thing, right? Ignore the thing. Complete it. What do we need to complete it? Well, we cut that rectangle in half and it kind of tells us what we need, right? A square. 12 by 12. 12.
Yeah, what's the 7 for? It's like not like
The 7 is extra, we ignore it. It's added on at the end.
Right.
It just happens. It's a line. Remember what this represents is a square that's x by x, right? A rectangle that's 24 by x, and then a line. That's 7, right? It's extra. We're going to make a square out of that, and then we'll just keep that for later. Okay. So, here we go. I got a worksheet for you.
Worksheet?
Yep.
And it's off.
Can I stay after school to finish my test?
Yes, great idea. Great
I have a
idea.
pass.
Where did I put
have a
it?
pass phone or
Where did I put it? I will, but I'm not writing it right now. Oh, here it is.
This is my.
You get it.
Did I come in?
Mr. Mack, that's the answer key.
Most things that you weren't healthy in the object.
Of course, you don't need to ask. Yes. So I'm giving you a bunch of standard form parabolas. We're going to convert them into vertex form because standard form is pretty much useless for graphing. Right? Like, yeah, it's a lot of numbers, but what does it look like, right? Yes, correct. 71.
Wait, the answer.
You'll see. All right, so number 1.
Yeah, I know that. But like,
Now we know what this represents. It's a square that's x by x, a rectangle that's 16 by x, and then a line that's 71 feet or something long, right? Okay, we're going to ignore that. Who cares? We want to make that into a perfect square, right? So, x squared is the square. How big are our rectangles going to be once we cut them in half? 8 by x, right? Which means we're going to have something like this. X by x, 8 by x, 8 by x. So how big will our leftover be?
8 by 8.
It'll be 8 squared, right? 8 squared. So we're going to add 8 squared to both sides. Y plus 64, otherwise known as 8 squared, right? Equals x plus 16x plus 64, and then the 71 we're just going to hang out on the side, okay? Again, simplification is simple because it makes it easier to work with stuff. Adding that together doesn't make anything easier for me. I just made a perfect square right there, and then I got a little tag along, okay? So, what are the dimensions of the square that we made?
8 squared.
X plus 8, right? We usually do the variable first. See how that's 8x plus 8 in length? Right? This is x in length. That's 8 in length. So together they're x plus 8. So this side is x plus 8. And then this side down here is x plus 8. Okay? Cool. So x squared plus 8x plus 8x, that's 16x, right? The 71 we're just going to stick on the outside. We're not trying to make that perfect, okay? What's left over we need is 8 squared. Does everybody see why that's 8 squared?
Yes.
Because it's 8 by 8. Okay. So we add 64 to both sides. I'm just sticking to 71 on the end. I don't care about that. Okay. What are the dimensions of our square? X plus 8, right? That's how big that side of the square is, by x plus 8. So the whole thing is going to be equal to x plus 8 squared. Jordan, you with me on that? So all of this is really just a really convoluted way of saying x plus 8 squared. Now we have a plus 71, right, on the end. And we've got a 64 over here still, right? Because we had to add on a bit to get to the square, right? Not everything's going to be a perfect square right at the bat. Okay? So we're not done yet, but we will be. Does everybody see how I got the x plus 8 squared? Right?
Sort of.
That side is x plus 8, that side is x plus 8, so this square is x plus 8 squared. Now, what does this represent? Well, it represents all the pieces we cut the square into, right? A square of x by x, two 8 by x rectangles, and then 8 by 8 square, right? We cut this square. If we're going backwards, it's cutting the square into different pieces, right? And those are the pieces. Okay? We put it back together, and we said the square was 8 plus x. Okay? We subtract 64, and we get y equals the quantity of x plus 8 squared. What's 71 minus 64? Well, 70 minus 64 is, try again, 70 minus 64? 6. So 71 minus 64 will be 7, right?
I get it. I just have to like have the squares to know.
Yep. But that's good, because that means you understand what's actually going on. Everybody else is like, have it, square it, add it on both sides, do it, right? You'll get that eventually. But right now, don't worry about it. Let's look at this one. Now, we're going to have negative rectangles. That's okay. It's okay. It just means we're heading to the left instead of the right. That's all negatives mean. They're just directional. Okay? Our rectangle's going this way instead of that way. It's fine. Okay? We have a square of x by x, right? How big are our rectangles going to be once we cut them in half? Yeah, oh, I'm sorry. We have a square of x by x, right? We're going to have rectangles that when we cut them in half, how big are they? Negative 1 by x. It's negative, it's fine, okay? So that little bit right there is going to be negative 1 by negative 1, right? What's negative 1 squared? 1, right? So that's 1. We're going to add on 1 both sides. It was so close to being a perfect square. We just had to add on a little bit more. Yeah?
So are we just basically taking what's x and just dividing it by 2, and that's what like will be around the square?
Yeah, that's the algorithm. I'm explaining why.
Okay, just wondering.
It's okay. I will need you to show me why on a quiz when I quiz you, right? I want to see this type of thing, right?
Yeah.
Now, if you notice, the dimensions of our square are x minus 1 and x minus 1, right? That's it. So it's x minus 1 squared. Right? If I told you the dimensions were 2 by 2, you'd say 2 squared, right? But it's x minus 1, so it's x minus 1 squared. So all of that, except for the minus 5, we didn't pay attention to that, is just going to be x minus 1. Now, in order to get there, what do we have to add on to both sides? We had to add on to 1, right? Right? I skipped a step in between. Before I added the 64s to both. Oh, sorry. I'm using it. I added 64 to both sides, right? Right. I did that. And then the 64 went away and became this, right? Because that's all perfect square. I just skipped writing the 64 and just went straight to it. The 71 stays, the 5 stays, right? I have to remember to put it over there, though. Right? And I move it over. So we're done. Okay. How do you solve the problem? Like Maria, now we have a negative x. Yeah.
For the one just over there, how'd you get y plus 1?
So, Jace, I kind of skipped a step. We had to add on 1, right? That's what that says to both sides. So we have x squared minus 2x. The plus 1 I'll do first and the minus 5 later. Remember, all of that becomes this.
Oh.
So it went away. Yeah, you see what I'm saying?
Oh, okay, I see it.
And then the minus 5 stays.
Yeah, I see.
Then we move over the 1, we get the minus 6.
Yeah, I see.
All right. Now, problem. We have a number in front of x squared. Negative 1, right? Does it work? Now let's check what the answer is. 3. Has a negative on the outside. Interesting.
So negative doesn't really affect it.
So would it be true Let me get some big paper here. I'm tired of writing in small margins. I hate these worksheets. That's why I normally make my own. Here's the original problem, right? Okay? If I gave you this, would you know how to solve it? Yeah, cut it in half, do the thing, right? So how about we just treat it like it's that, and then at the end we negate it?
Yes.
Does that make sense? See, I pulled out the negative from everything. What did I do? I pulled out a negative from everything. So negative x squared becomes x squared. I do it to every term. It's kind of like division, right? I pull out the negative from here, pull out the negative from there. Now, if one of these was positive and I pulled out a negative, what would happen?
That would turn negative.
It would turn into negative, right? I did that, so I have a problem I know how to solve, right? When you're doing math, don't know how to solve it, make an easier problem and see how it relates. Right? It's the same problem as we were doing before, just we're going to negate it at the end, right?
Correct.
You see how those are related?
Yep.
Okay, so we're just going to do this over here, and then the rest of our work is going to be done inside this parenthesis. Now, what's half of our rectangle?
7.
7. So we have to add 7 to both sides, right?
Yeah.
7 squared, right? Because the 7s make the 7 squared. So we're going to add 7 squared to both sides. And then in here is going to be what? X plus 7 squared. I'll slow that down. Well, when we do our rectangle, right, we're going to have x squared plus 14x plus half of that squared. What's half of 14? We square it, we get this. We have to add 49 to both sides, right? Cool with that?
Wait, why is there a 49?
7 squared.
Oh. Wait, there was like it was x plus 7. Divided 14x by 2. But there's no x by 7.
When we make our rectangle, we have x by x, right? That's what that means. Then we have 14 cut in 2, which is 7 by x. And how big is the remaining? 7 squared, which is 49. Right? So we have to add 49 to both sides. We got to complete the square by adding 49 to both sides, right? And then now that's a complete square. So we get this. Right? X plus 7. Right?
Where'd the x go?
Oops, sorry, 49. Right?
Where'd the x next to 7?
This guy?
How is x is by 14 but it's not by 7?
If you went backwards, you do x times x, x squared. X times 7, 7 times x, 14x. 7 times 7, 49. If I wrote that twice, you know what I'm saying? Okay. So it goes away, right? Because now it's a perfect square. Now we have a problem. Because when I do this, what do I get? Let's subtract 49 from both sides. What am I left with? 10. What's the answer? What's the answer supposed to be? Minus 10.
You didn't negate it.
No.
Let's see, where did he screw up?
When I added 7 to both sides,
Are you supposed to
Did-
subtract it?
check it out. When I added that 49, right? What I really did is I subtracted 49 because that negative is going to go back into it. So I wanted to add 49.
How'd you get
Yeah, minus 14 halved, right? Is 7. 7 by 7 is 49. That square right here is 7 squared, which is what that is. Remember I added that into my square to complete it? That's what completes the square and allows me to make this.
Why isn't it? Why isn't it minus?
So it's going to need to be a minus 49 here, right? Because it's negative. If it's positive here and I send that negative out, it's like I subtracted 49 to this side, right? And I added 49 to that side. That doesn't make sense. If I add 49 to this side, I got to add 49 to this side, which means that needs to be a minus. Are you cool with that? So that needs to be a minus to make it positive.
Why isn't it minus? 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 Why
So that's gonna change things. Let's talk about that.
Oh, erase everything.
Let's talk about that. If I've got this, right? That'll turn into this. Right? Cool with that? Which will turn into this. But then when we distribute the negative, what happens? Minus 49. Right? So if we want to add something inside here, right, inside parentheses, we have to be aware of what's on the outside, because it's going to affect it, right? So this makes things complicated. Let's try number 3 again. All right. I'll see you guys tomorrow.
We can. She's gonna work it.
Oh, I guess my subscription is lifelong. I mean, we're around.